Today I'm going to do a video of this PAL 351B I have. I bought this off eBay a while ago, maybe a year, I don't know. And when the seller shipped it, he basically didn't do any packing with it. The tubes were bust up, the chassis was bent, and it was a dust bunny, piece of junk. And I was trying to get rid of it as is, but it looked like nobody, wants to take a chance as is. So I cleaned it up, wiped it down, gave it some spray, a little bit of time, put some new set of matched tubes in it. Well, actually not matched. They're all 6JS6C tubes, but two of them are Sylvania and I think two of them are GE. And originally this had 8950s in it, 12-volt version of this tube. 8950 is a 12-volt version of the 6LF6. And the 6JS6C is a replacement or interchangeable pretty much with 6LF6. So I had some 6JS6s running around, so replaced the tubes, broke up tubes when I got it. One of the reasons I got it or bought it because it had 8950s in it, and of course then I get it, and I think 3 of them were busted and 1 was usable, so that was kind of a bust for me. But anyway, we got the PAL 351 going with the tubes. Had to do a cap job, of course. Those are the new caps in it. These are the old caps in this guy here, and if you can look, that's pretty bad. Old caps dry up, and you fire the thing up, especially without using a variac. With those in it, things might go bang, or they short out, and then they take out the power transformer, and then you got real problems, because finding a transformer that fits these amps with the right voltage or close to it and the amperage and something that fits is not easy, especially one in a small package like this one. This one got a little bit of rust to transformer, but all in all, not too bad. Also, it did have a preamp in it, and it had a preamp relay, but the relay looked real bad. Where are you, relay that's in there now? Let me turn this thing. Yeah, there you go, relay. So that's the antenna relay, and then it had a preamp relay sitting next to it, but we took that out because it looked so bad, and we took out the preamp circuit. We just bypassed all that, so this amp no longer has a preamp in it. It's just a straight 1 driving 3 grounded grid amplifier. And basically, here's the original schematic of it. And this is the driver tube. And you see all those dotted lines and solid lines inside of that? This circle represents the tube. The bottom that's shaped like that is the cathode or the ground. And these dotted lines would be the other grids, and then the top would be the plate. And if you see down here, these 3 grids here are all tied directly to ground. And that's what they mean about grounded grid. If one was running a tetrode mode, this center grid would be the turbocharger one. That's the one, if you go on tetrode, did I say turbocharge, you get very high gain off of it. And then this grid, first dotted line to the left, on a tetrode is the input. That's your input grid. So when you have the input going to that grid is high impedance input, like a Black Cat. And the Black Cat, that's why they have that variable tuner going into it, because you got to raise the 50 ohms coming in to about 10K, 5K. Something like that for the input of the grid there. But when you go grounded grid like this one, it's a much simpler design. You don't need no screen voltage. You don't need no bias to like water cool that turbocharger, because you don't have a turbocharger. So on this, you got all the grids grounded. You got the plate voltage coming on top. And you got the ground actually going through here. This coil here is a RF ground. Whereas the, well, I shouldn't say it that way. It's a DC ground. Where the DC, or the voltage that's not RF, is grounded through here. But RF cannot go through this coil. So it's like an open circuit for RF. So your RF coming in through this cap here goes into the cathode of the tube. That's how grounded grids are. They're driven by the cathode of the tube. And sweep tubes like this, the input impedance of a grounded grid is about 120 ohms. So one tube, that's about 120 ohms drive. So it's not going to have a great match going in, not being input tuned, but it's not going to be totally terrible. It's going to be like 2 to 1. But over here, if you got like a 3-tuber or a 4-tuber at 120 ohms a piece, it's going to bring it down to like, 60 or 30 ohms, and it's going to be closer to a good match without, having an input tuner. I was just noticing, I'm like, this 351, where's the other two? But it just mentions here 3 tubes, so it just shows 2, even though it's a 3-tuber. A 3500Z tube is grounded grid, and a single 3500Z has a input impedance of 100 ohms. So you put 2 of them in parallel, you already got 50 ohms going in, so you can have a fairly decent match of a 3500Z dual amp, even with an untuned input. But it's better to put a tuner on there, some kind of type to help smooth out the RF and all that. But basically, a grounded grid amp, 1 grounded grid tube here, driving the 3 grounded grid tubes here. Pi output, that's the tuner there in between the driver tube and the final tube, and that's the variable tuner here. You tune it on the back here. One reason I wanted to show this, I keep saying 4 turns, 4 turns. Well, 4 turns is kind of a generic average for the tank coil, which is that coil there in between the tune and the load. And I kept saying 4 turns because that's kind of generic for 4 or 5 tube amps. But the less tubes you have, like this one is a 3-tuber, and it's even written here. I did not do that. This is a factory schematic, and it's saying 5 turns for the 3 tubes here, and then less tubes you have, the more turns, right? So there's your driver tube, and this is from the factory, 7 turns. Less tubes you have, the more turns you need, and the more tubes you have in parallel, the less turn. Like a 10 tube or a 12 tube Phantom has about 3 turns for all those final tubes on it. So anyway, that's my 7-turn coil, and that's my 5-turn coil right there. Factory, and this amp is made for basically 10 through 15 meters, 11 meter amp. So I think that's all I wanted to show. So let's turn her around and fire up this resurrected junky 351. We got voltage on it, so we're gonna stand back and zoom in. It cleaned up pretty good. You'll see spots and stuff where I missed some of the dirt and all that. Tram Doctor's not a neat freak to make them look super pretty, and that didn't do nothing for the front. And the cabinet is a little bit cockeyed, a little bent still. I'm an old man now. I used to have my Superman muscles and might could have straightened it out, but I'm like, forget that nowadays. And so anyway, over here we got power on, off, transmit, standby, receive amp, which is no longer in effect. You don't got no receive circuitry or not even a receive relay in it. High-low side, AM SSB switch, and all the AM SSB switch does is put a delay on the relay. And you got your what's marked as plate and antenna. Basically, the plate is plate tune, because you're tuning the plate, and the antenna is antenna load. I've said in videos a few times already that basically the tune tunes the tubes, or the plate of the tubes. The output of the tubes, like I said earlier, is called a plate. And I'm glad this one is marked this way, because the plate tunes the tubes, and the load, which this is marked antenna, tunes the antenna, or the dummy load, or whatever you're putting this thing into. If you're putting it into a bigger amp, it'd be driving a bigger amp, not an antenna. So anyway, I guess we warmed up. Hope nothing's out of tune for me moving it around and playing with it. Using the Mud Duck Midland today. Not doing a lot of watts, and on a dummy load. So we're going to key her down. And that's the input SWR, 1.9. This here watt meter is on the 20 watt scale. And that's the input of this amplifier. Audio. So I'm only doing like 3.5 audio. Swinging to about 7 going into it. Not a lot into it. And over here, I didn't want to be on the 2000 watt scale. I didn't want to be on peak either. So we're on the 200 watt scale on average, and that's the output going into a dummy load. Audio. So only doing a 100 watts, dead keying 90 audio, swinging about 110. Whistling to about 150. My whistle broke again. I get that way when I'm dry. And I'm going to put it on the 2000 watt scale in peak last. Audio. Peak about 275, I guess. Hello. That's not bad for what's going into it. I'll even show the peak watts going into it. Need another hand to do all this. Audio. 15 peak watts in. Audio, about 275 out. And that's the PAL 351 BDX. One other thing I wanted to show though is this uses a voltage doubler. This is the power transformer. That's the high voltage. And that's the voltage doubler, where one winding of the high voltage goes to the center of the diodes, and the other one goes into the center of these two capacitor banks right here. But what I wanted to show that is the relay, the same single antenna relay, is in series with the winding for the high voltage. So this one cuts off the high voltage completely until you key down the antenna relay. Until you key it down, it's got no high voltage going to it. The one thing I don't like about that kind of thing, we do like that the high voltage is cut off, but when you do it that way, every time this amp is keyed down, it's got to charge them capacitors from 0. These are the bleeders, so those bleeders, where's the other one? Right there. The bleeders are taking it down. So and there's no voltage on it till you key down. But when you use a voltage doubler, it takes it a minute for it to charge up those capacitors, because it's basically doing a half a cycle. It's going to charge the bottom capacitor up a little bit, and then it's going to try to charge the top one, capacitors over here, up a little bit, and until the bottom one gets charged, the capacitor, the top one, isn't going to have much voltage or a good basically ground to send off on, if that makes any sense. But anyway, you're charging half cycle, so you're not hitting everything at once. So it's not that hard on it when you have a voltage doubler circuit. And by the way, a Heathkit SB220 has an undersized transformer and uses a voltage doubler, and hence it doesn't have any resistors or self start mechanism, because it's nice to have, but it really don't need it with the voltage doubler and the undersized transformer. And this one doesn't have a great big you know, powerful transformer either. You know, it's appropriate for the size, but with that voltage doubler scheme, you really don't need self-start and surge resistors and all that, because it takes it a second to charge up those capacitors. And I think even when I keyed it down, yeah, you can't really see it on the peak in that scale. I'm going to let those caps discharge a minute. But the first key down, it takes it a second to build up that voltage, because that's the capacitors charging. As I've said many times before, the capacitors charging pull a lot of current. But anyway, with the voltage doubler, it's not as bad. So hopefully those caps are discharged, and you can see the watts build up there. See that? That's those capacitors charging. Those are brand new, you know, good capacitors in it, and that's normal. That's that voltage doubler. When those capacitors are dead, see, it's charged up now. I'm not giving it enough time to discharge. But if I let that, you know, unkey for a while and let those caps discharge, it would take a second or two for those caps to build up, and that's why the wattage does that. That's normal with that voltage circuit. Here we go. That is normal. Anyway, that's it for this PAL 351 BDX. Not a pretty thing and all that, but at least revived from the junk pile. That's it for this one. Bye.